What's up guys? My name is Alex and in today's video we're going to talk about Microsoft Flight Simulator 2020 and its multiple monitor setup problem. First off, I'm going to go over what that problem is, and then if you're looking for a solution on how to set up multiple monitors, I'm going to present to you a solution that kind of works, but then I'm going to go over deeper into what that problem is from a game developer's perspective, and then finally I'm going to present to you what I think a possible solution might be also from a game developer's perspective. Now, I should note that I'm not affiliated with the development of Microsoft Flight Simulator 2020 or Microsoft in any way, but I am a game developer. I'm currently working on Call of Duty Modern Warfare, so I kind of know the inside of how games are built and why setting up multiple monitors with this game might actually be a problem. So without further ado, let's take a look. Okay, so before we begin, let me just show you what I'm working with here. In the middle, I have a 3440 by 1440p monitor, ultra wide. And then on either side of that monitor, I have two 1920 by 1080p monitors. The important thing to note here is that the vertical resolution of the middle one is 1440p, and these guys are 1080p, because that's gonna come handy later. Okay, so in the old Microsoft Flight Simulator, we had the ability to have these separate windows or panels, if you will, and point them at different sides of our plane. So you would point one of those screens in front of you and put it on the screen in front of you. Then you would have a separate panel looking over to the left or the right, and then you would move that panel to the left monitor or the right monitor. And that way, by using these panels, you can actually surround yourself with views from different points of that plane so that you can actually get that kind of 180 experience. So in the current version of Microsoft Flight Simulator, if we go under Options and then General, you'll see that display mode is set to full screen, and we have the option to choose from full screen or windowed mode. And then I'm running it right now in full screen on my center screen, and then at full native 3440 by 1440p resolution. Now the only option we have right now to run the game on multiple monitors is to actually switch away from full screen and into windowed mode. And then by doing so, this allows us to actually stretch the window onto the other screens on the sides as well. And I'm actually going to switch back to my cell phone view for a second here, just so I can show you what that looks like. Okay, so this is the game running in windowed mode now, and I'm going to focus here on the boundary between the game window and the second monitor. So if I just grab the corner of that window and I just drag it off to the side, you see how I'm actually extending the game window to encompass the second monitor here as well. And then I can do the same thing on the left side. I don't know if you can see that. Let me just try and get here. Okay, here's the boundary, and I can just grab this and extend it this way. And now the game is extended to that monitor as well. So you can see now the game running over there, and then on my center monitor, and then on this side as well, going into this monitor. So you can kind of stretch the game like that to run on multiple monitors. However, there's a problem with this, as I'll explain right now. So remember in the beginning I said that the middle monitor is 1440p and then the side monitors are 1080p. Well, that's a problem now because and here's what I'll do to show you that problem. I'm actually gonna grab the bottom portion of that window, cursor right here. Look what's happening in between the two windows now. If I start moving this up, I'm actually making the window smaller or narrower on the middle screen, but on this screen right here, it's not moving yet. And I have to keep going up, and then at some point, oh, there we go. So you see the discrepancy between the middle monitor and the side monitor? That's happening because the middle monitor is at a higher vertical resolution compared to the side monitor. So if I go and move this this window over here, what I'm essentially doing is over here in this monitor, I'm actually cutting off the bottom portion of that game area, and I'm kind of moving that bottom portion outside of the boundary of that screen. So if I just leave my game over here, see what that looks like now. Now on the middle screen, I'm actually running the game in a super kind of vertically narrow window where the bottom portion, the portion right here, is being unused. But over here, it's almost towards the end. And this is kind of expected because the vertical resolutions are mismatching. However, it's kind of a problem with the way this game is designed. And this is going to be a problem for you as well if you're like me and you're running multiple monitors that don't have the same vertical resolution. And I'll explain what that problem is. So if I go to the flight training menu, and I go on to start the test flight. Click fly over here. Now take a look at what's gonna happen. As soon as the game loads, it's gonna actually prompt me to start the game, but look at where the button is. There we go. So the button is right here in the corner. So this button that says ready to fly right there in the corner is the button you need to push to actually start the test flight. Now, this is fine the way I have it right now, even though it looks kind of off because these two screens are not matching up. But if I were to just grab this screen over here in the middle and extend it downwards, now because I'm actually cutting off the game in this portion over here, I can no longer really start the game because I have no access to that button to start the flight. And that's kind of the main problem when you're running multiple monitors with different vertical resolutions. The other problem obviously is that the images that you see here and here are not really going to match up perfectly. But honestly, I can even live with that problem, but I can't really start the game this way. So if you're lucky enough to have a setup where all your monitors are the same vertical resolution, then this is the only way right now where you can set up multiple monitors with Flight Simulator 2020. Go in window mode and just stretch the game to fill up all your monitors. The only other solution would be to get an ultra-wide screen, even wider than what I have over here, to fill up most of your field of view. That way the game will run on a single screen and fill up most of what you're going to be looking at. Now, I've seen a lot of people online complain about this fact, the fact that Flight Simulator doesn't support multiple monitors in a better and more native way. And I just wanted to jump in defense of my fellow developers over there and talk about why I think this is, and that's what we're going to be discussing in the rest of this video. Again, I want to stress out that I don't know this for a fact because I'm not a developer in this game. These are just my thoughts on what I think the problems might be by supporting multiple monitors in this game. And the short explanation is that I think the game just looks too good to support multiple monitors. And I'll explain what I mean by this. But in order to do so, I have to introduce two concepts. A concept of a view frustum and a concept of object culling. And I'll talk about these now. So you can think of the view frustum as a box in front of you. When you're looking at the game world, you have your monitor in front of you and you're looking at the game world in front. So if you think of this world frustum as a box, but not a rectangular box, but a box that kind of starts flat in front of your face somewhere over here and then kind of expands as you go into the world. So it's a box that's kind of irregular shaped and it expands kind of narrower or wider depending on your field of view. And then at some point in the future, there's what we call a far plane. So this is the near plane and then there's a far plane and that's a cutoff. And we say that, okay, the far plane is just way into the distance and we won't render anything that's outside of that far plane. So basically anything that falls within that box, within that view frustum box, is what's going to be rendered. That's what you can actually see in the scene. So if you think of the game world as a room and you're standing in that room somewhere and facing some direction, anything in front of you is basically in the view frustum and is things you can see, and you can kind of see off to the sides a little bit in your peripheral vision, but it doesn't like go all the way. And anything that's around you is the game world. So the game world or the room exists behind you as well, and even to the sides of you that you can't really see in your peripheral vision. So the world is there, you're just looking at a very tight, narrow piece of that world. And what we use to actually kind of give you a look into that world is a camera. So that camera is positioned where your kind of face would be in the world, and that camera is looking out, and then anything that's in the view frustum is things that you can see. Anything outside of the view frustum you can't. The concept of object culling is also kind of simple to understand. Basically, as we said, the world exists outside of what you can see. The world is all around you. But when you're flying your plane and you're looking ahead of you, you're not going to be seeing things that are behind you or maybe below the plane or maybe even to the sides of the plane if it's far enough to the side that you can't see it in your peripheral vision. So at that point, those objects we can actually cull or essentially hide. We don't have to worry about them because they're not in your vision. The same thing happens if you have, let's say, a tall building, and you're looking at a tall building and there's a smaller building behind the tall building. So because the smaller building is obstructed in your view by the tall building in front, that building is going to be culled or hidden by the tall building. And this is actually kind of obvious if you're thinking about rendering, because when you're looking at something, you're rendering a scene on the screen, obviously the small building is going to be hidden by the tall building, right? The thing with object culling is that we're not just hiding that small building from the renderer, we're actually not performing any math on that building either. So any object in the game is comprised of these polygons or triangles at the very basic level, and these triangles are comprised of 3 points to the triangle, on the edges of the triangle, and those points are called vertices. So every object in the game can basically be expressed in order of these vertices. If I tell you where all the vertices are, you can construct those triangles, and then those triangles are gonna make polygons or faces, and then eventually you're gonna get a tree or a building or anything like that. Now you can think of any object in the game expressed in terms of these polygons, triangles, faces, whatever you want to call them. So there's some information behind every object in that game. Now, when we're kind of calculating what we're about to render on the screen, we're taking all of these objects that are visible and we're actually passing them on to the renderer. So if you're looking at your camera into your little view of the world, and you're looking at that big building, we can perform some math to discover that, hey, there's a smaller building behind this big building, but it's not going to be visible because it's obstructed by the big building. So anything that we had to calculate in order to represent that building, in order to, we had to actually grab those vertices, those faces, and figure out where they are in space and where they're going to show up on your screen. We can actually get rid of all of that. We don't have to do that work. And in game development, whenever you can avoid doing some work, you absolutely take the chance to do so, because the less work you do, the higher the frame rate of the game would be and the game would play smoother. So when we're talking about object culling, what we're essentially saying is, hey, we know for some reason that this object is not in our view right now, so we don't have to do any sort of calculations on it. So for example, when you think of the game world and everything that's around you, if you're flying your plane and you're kind of looking straight, you don't have to worry about anything behind you. So we can perform object culling on all of those objects, be it trees, buildings, or anything. And if you actually change your view and you kind of look backwards in the seats behind you towards the back of the plane, now all of a sudden we can perform object culling on anything that's in front of you. So you don't have to do any math on anything that's in front, trees or buildings or whatever. You don't have to do any math on the instruments themselves. Obviously, we need to keep track of, let's say, the airspeed so that we know how fast the plane is moving through space. But the instrument that actually shows the airspeed, well, now we know that that object is not visible, so maybe we don't even have to calculate where that needle is supposed to be on that element, on that airspeed indicator. And again, I don't know this for a fact because I'm not working on this game, but that's usually how things go. Whenever you can avoid doing the math on something, whenever you can avoid doing the work on something, you choose to do so because that raises the frame rate. So object culling or occlusion culling goes hand in hand with what we said when we were talking about the view frustum, because when you can calculate what's in your view frustum, you can also calculate what's outside of your view frustum, and that thing can get culled. And then the more objects you can actually cull or not worry about, the more you'll raise your performance and thus raise the frame rate, and that's obviously better for the game overall. Now let's go back to tying what we just said about the view frustum and object or occlusion culling, and then how that relates to why we can't run Flight Simulator on multiple monitors. Well, remember what I said about the previous version of Microsoft Flight Simulator. We had these windows or panels, and we could actually adjust those panels to show a different portion of the screen or a different portion of our plane, and then put those windows on our different screens so that we can actually get a 180 view of our plane. Well, if you think about those individual windows or panels, those are all separate cameras because those are all pointed at different parts of the plane. So if you wanted to, you can have one camera pointed in front of you, another one pointed to the left, another one to the right, and then another one maybe as a rear view mirror pointed behind you. Well, if you were to set all of this up in Microsoft Flight Simulator 2020, Now, all of a sudden, you end up questioning yourself, like, what can you really call? Because now all these cameras have their own view frustums, and they can all view individual pieces of the world. So now you have, let's say, 4 cameras pointing at different pieces, and all of a sudden you run out of objects to call. Now, this is not a problem when your game is kind of old and lower resolution, and the textures are not as detailed and not as complex. Remember, we're talking about those vertices and triangles and polygons. When you're dealing with an old game, usually each object is going to have fewer of those, so it's going to be easier to actually render them out on screen. But with a game that looks as beautiful as Microsoft Flight Simulator 2020 does, now all of a sudden you have very detailed objects and very detailed textures, and those are difficult or expensive to render in terms of performance. So now when you have, let's say, 4 of these cameras to worry about, that becomes a problem, because all of a sudden you just don't have the horsepower in a typical PC to actually render all those. And I think this is where the root of the problem lies. Basically, we're just not there yet in terms of performance to allow for so many different cameras to be rendered at such a high resolution with such detailed textures as these games allows us to. Actually, a similar problem exists in other games when they try to render mirrors. If you go back and check out some games that are really old, you might find games where mirror surfaces were just kind of silver colored and they weren't actually showing a reflection at all. Now, in a bit more modern games, you could find mirrored surfaces that were showing a reflection, but the reflection was kind of low resolution and maybe not as showing things in great detail as the actual game world was. And then if you go on in games that are kind of recent, then mirrored surfaces might actually be perfect and flawless and show a very accurate reflection. And this is because it's kind of the same problem. You're rendering the world once from the point of your camera looking at the screen or at the game world, and then the mirror has to actually render the opposite screen. So there's a separate camera looking towards you from where the mirror is, and it has to render the opposite screen. So you're actually rendering the game world twice. And that's kind of the similar problem. And that's why games earlier on couldn't actually do this, because they now had to render the game world twice, and games these days can, because we found a lot of optimization, and also the hardware, CPU and GPU speed is going up, so we can actually do that. So it's kind of a similar problem, and I just thought of giving you guys that as an example so you can understand why rendering multiple cameras at the same time is kind of a complex problem to solve. If you think about the game Portal, they actually, the reason that game is great is because they actually managed to render the game world and also render the scene behind the portal, and then even found a way to render portals that are looking into each other, sort of as this infinite loop kind of thing. So that was actually a great achievement in terms of game development, and that's why that's actually so amazing, because they found a way to do this without actually decreasing performance. So going back to Microsoft Flight Simulator again, the fact that it's difficult to render multiple cameras at the same time, and you actually have to do that in order to set up different panels looking at different portions of the game world, that's what makes it difficult to implement multiple monitor setups right now. You might be asking yourself now, well, I have a $10,000 PC, right? I have 5 GPUs in there, crazy CPU with, I don't know, 50 cores. My computer is just off the charts. Surely it can handle rendering, 3 cameras or something like that at a super high resolution. And the answer to that is yes. Technically, in that case, if you have a super high-end PC, this should be doable. However, from a game developer's perspective, you always want to target the majority of the people, because in essence, game development is a business, right? The bottom line is that we all want to sell more copies of our game, because that way we make more money, and that way you can actually even create newer games, better games. You can afford paying more people, increasing the size of the game developer studio, etc. So if you only target the 1%, not even the 1%, that's not a great way to actually place a game on the market. You actually have to target the most people you have. So that's why you can't really think of, hey, let's just please this minority of people that have the performance necessary to run this game on multiple monitors. Now, on the flip side of that, you can also argue, well, okay, then just decrease the performance of the game to a bare minimum so that 99% of people that have PCs out there can run it. It can run on a potato machine. It doesn't matter, right? Well, that actually hits a different point in game development, where one of the marketing things, one of the ways that one of the ways that they marketed this game was they said, "Look at how beautiful it looks," right? So if you think about it, even the old Microsoft Flight Simulator was simulating flight. So the simulation portion of it is not new, it's not revolutionary. However, one of their selling points, their marketing points was, we can do the simulation, but you can also enjoy the flight while you're actually flying the plane. And that's because the game just looks so amazingly well. Now, if you only target the bottom portion with a very low resolution and you target 100% of PCs out there, well, all of a sudden you're kind of losing that marketing point, because people will start taking screenshots of their game and your game kind of looks like and no one really wants that. So you kind of have to target that sweet spot between the high end and the low end, so that you can hit a large number of people able to play this game while still keeping that baseline minimum of a visual fidelity that you want, so that you can actually promote the game as this beautiful thing that everyone wants to look at. So I mentioned at the beginning of this video that I actually have an idea of something that developers could maybe do in the meantime that's not really truly the multiple monitor support we had in the previous generation of Microsoft Flight Simulator, but it's actually a little bit better than what we have now. And the thing I was thinking of is, what if we render the game at a super high resolution that's big enough to actually encompass all of the screens? Now, we have to discuss something called the frame buffer. What the frame buffer is in game development is basically the piece of memory where the information about each individual pixel that your game is supposed to render a screen goes. So if you think about the frame buffer as kind of your screen, then every single pixel on that screen will get a little bit of memory in that frame buffer, and then you will put the color of that pixel in that frame buffer. So everything that's in the frame buffer eventually goes to your GPU and then is rendered on your screen. So in my case, I have two 1920 by 1080 monitors and then one 3440 by 1440p monitor. So if I were to render a frame buffer that kind of encompasses all of those together, and then take pieces of that frame buffer and map them, if you will, to the individual screens, I could kind of get that surround effect with multiple monitors without having to render multiple cameras. Because it's still going to be a single camera looking out at the world, is just going to be rendering a larger FOV at a larger resolution. Now again, the problem points that I was mentioning before still kind of apply here. You need a very powerful PC to be able to render a resolution that's kind of a sum of all of the resolution of these multiple monitors. And you actually have to have a very large field of view, FOV, to actually be able to render enough of the scene so that you can map it to the individual monitors. But at least in theory, if you can render a scene that's large enough, you can kind of take a piece of that scene and apply it to your center screen, and take the side pieces and apply it to the side screens. And in my case, obviously, because I have different vertical resolutions, what's going to end up happening is the scene I map to the side screens will actually cut off a little bit of that scene, because I'm going to render a 1440p for the vertical resolution for my main screen, and then for the side screens I'm gonna still render the 1440p, but I'm just gonna take a chunk of that 1440p and I'm gonna apply it to the side screens, and that can kind of deal with this problem. Of course, we still have the problem of the UI that I mentioned in the beginning. The UI will have to be smart enough to not position elements outside of the areas that are mapped to be applicable to the screens. So that little button that actually allows you to start the game will have to actually be remapped or repositioned to fall into those areas where I actually want that button to be. Again, and I've said this several times, I'm not actually working on this game, so I don't know if any of this is doable. I just thought it would be a nice thought experiment to actually think about what the problem might be, and then what a potential solution might be, at least until we get to a point where we can actually have a hardware that's powerful enough, or algorithms that are fast enough to actually utilize the hardware that we have now and actually allow us to run multiple screens the same way as the old Microsoft Flight Simulator. And hardware is getting faster and faster all the time, and algorithms are getting optimized. So I have no doubt that in some point in the future, this might be added as an update or a DLC to the game where you can actually set this up in a proper way. You have to remember that another thing that's very common in game development, is deadlines, obviously. So if you have to choose between shipping a game on the date where you're supposed to ship it or shipping it later because you actually wanted to add more features to it, well, it's generally preferable to ship it early, as long as obviously it's bug free and works well enough to ship it early and then add things later on. Earlier on, way back when, game would go on disk and the disk would get printed and that would be the game that you play, bugs or without bugs. But these days, because it's so easy to patch games and add DLCs and add updates, it's actually preferable to ship the game, get it into people's hands. They can actually even kind of continue testing the game for you and then add stuff on after the fact. So they might have just as easily decided to do it this way because, well, the game is out, you can play it well enough on a single screen and it still looks gorgeous and amazing and it's amazing to play. And then maybe they'll continue working on multiple monitor support behind the scenes and continue optimizing their algorithms and continue coming up with ways in which they can actually make this possible for us. And that's pretty much it, guys. Those are my thoughts on Microsoft Flight Simulator 2020 and the multiple monitor setup problem and potential solution. Let me know in the comments below if you think I'm onto something here, or if you think there's probably a completely different reason for why multiple monitors are not properly supported right now in the new version of Microsoft Flight Simulator. If you like the content of this channel, consider subscribing, liking, all that good stuff. And until next time, peace.